Okay, so we are going to do chapter 7 next, and it's going to be a carry forward of some of the things that we looked at in chapter 6. In chapter 6, we looked at relations and functions, right? We talked about the fact that some relations are linear, others are nonlinear. When we talked about linear relations, we saw that a line has a slope, and we saw different ways that we could find the slope of that line. We're going to look a little bit closer at linear relations in this chapter. And then we're going to use what we learned in this chapter to help us in the next two chapters, chapters 8 and 9.
You got a haircut?
No. But after this chapter, you'll have your next test. Okay? So after this lesson, then we'll do the quiz on 6.3 to 6.5. So things that we're going to look at. What is the y-intercept of a line? What is the slope-intercept form of a line? What is the general form of a line? We'll look at the x-intercept of a line, the slope point form of a line, and we'll look at parallel and perpendicular lines. So we'll start by looking at the slope-intercept form. We'll identify the slope and y-intercept of a straight line graph. We'll determine a linear equation using the slope and y-intercept. We'll rewrite linear relations in slope-intercept form. We'll see how we graph equations in slope-intercept form, and then look at some problems. So, many relationships can be modeled by the graph of a straight line. For example, a farmer purchases chicken feed pellets by mass, yet dispenses the feed by volume. When the farmer analyzes the feeding of chickens, the relationship between the volume of feed pellets in the dispenser and the mass of the feed may be modeled by a linear equation. So the reason for that is as the mass increases, then the volume will increase as well, and it'll increase at a constant rate. That's why it's a linear relation. Linear equations can be written in different forms. Each form can provide specific information about the graph. So the y-intercept is something that we're going to use for this slope-intercept form. The y-intercept is the y-coordinate of the point where the line or curve crosses the y-axis. The y-intercept is where the graph crosses the y-axis, which makes sense if you think about it. Y-intercept, it's where the graph intersects with the y-axis. And it can be found when x is 0, because to get to any point on the y-axis, you don't go left or right. You just go up or down. That is the reason that the x value is 0. So we're going to use that because the slope-intercept form of a line is a line in the equation, or in the form, y equals mx plus b. This is the slope-intercept form of the line because it tells you two things. M, remember, we've used M before, it represents the slope of the line. And B tells you the y-intercept. Remember, we said that an equation is linear if there are no powers in it. If there's no exponents, that means that it will be a line. I'm just going to do a little bit job of writing that. Okay, so this is supposed to be intercept. It's where the graph crosses the y-axis. So again, if you have an equation, we've already learned in the last chapter that it is a linear equation if there's no powers in the equation. If the variables are to the power 1 or there's no power written, that means it's a line. Now you can put the equation of the line in slope-intercept form by simply getting y by itself. And when you do that, you'll have y by itself on one side. On the other side, you'll have two terms. One term will involve the x. The other term will be a constant. There will not be an x. But the term that involves the x tells you the slope. The number in front of x, the coefficient of x, tells you the slope of the line. And the constant, the term that doesn't have the x, tells you where the y-intercept is. So that's what the slope-intercept form of a line tells us. So again, to write equations of a straight line graph, you can use the following two constants. The rate of change, or the slope, is m. The y-intercept is the b value. The equation of a non-vertical straight line graph, Keen, be quiet, can be written in the slope-intercept form, which is the form y equals mx plus b. M tells you the slope, right? Remember, slope is rise over run. B tells you the y-intercept. So if we look at these examples here, we've got a table of values and we have the graph. The slope can be found by counting. Go from one point to another point. So if we look at this graph, we know that the point -1, -1 is on the graph, and the point 0, 1 is on the graph. That line has a positive slope. As you go left to right, the line is rising. And you can find the slope by counting the rise and the run. So if you go from the bottom point to the top point, you're going to go up 2 units and over 1 unit. You're going to rise 2 and run 1. That's where the slope 2 over 1 or 2 comes from. You can tell just by looking at the graph that the y-intercept is at 1. That's where the graph crosses the y-axis. So m, the slope is 2. B, the y-intercept is 1. If you let m equal 2 and b equal 1, this is the equation of that line. If you know the slope and the y-intercept, you can write the equation of the line by letting m be the slope, b is the y-intercept. So the equation of this line is y equals 2x plus 1. This next line, we've got a table of values. Again, we can find the slope by choosing 2 points on the graph. So this graph goes to the point -2, 0 and 0, 1. To go from -2, 0 to 0, 1, you're going to rise up 1 unit and run over 2 units. Rise 1 over run 2 gives you a slope of 1/2. You can tell by looking at the graph that the y-intercept is at +1, so that's your b value. The equation of that line is y equals 1/2 x plus 1. M is the number in front of x, b, the constant, is the y-intercept. That's the equation of that line. So these first 3 lines all have a positive slope. For this third line, again, you've got a table of values. Remember, you can look at the table of values and know that it gives us a linear relation because x is increasing at a constant rate of 2. Y is also increasing at a constant rate. That constant rate is 1. But it is increasing at a constant rate, so it will create a line. When you put the points on a graph and draw it, you see that it's a line. And you can find the slope of that line by taking any 2 points. Let's use this point over here, which is -2, -2. And this point here, which is the x-intercept, 2, 0, you would rise 1, 2, and run 1, 2, 3, 4. So a rise of 2 over a run of 4, that fraction, 2 on 4, reduces to 1 on 2, 1/2. That's the slope of that line. Only in this case, the y-intercept is -1. That's why the b value is -1. So you let m equal 1/2 and b equal -1. The equation is y equals 1/2 x minus 1. Bless you. That's the equation of that line in slope-intercept form. This last one has a negative slope because it's falling as you go left to right. But we can find the slope by taking 2 points on the graph. The point -1, 1 and 0, -1. To go from the top point down to the bottom, you're going to rise -2 and run +1. That's why it's -2 over 1, which is -2. And the y-intercept, you can tell by looking at the graph. The graph crosses the y-axis at -1. That's the y-intercept. So you're going to plug in an m value of -2 a b value of -1. So this equation will be y equals -2x minus 1. That's the equation of that line in slope-intercept form. So again, slope-intercept form is where you have y by itself on one side. Normally on the other side there'll be two terms. One term will have an x, the other term won't. The term that has the x tells you the slope. The number in front of x is the slope. The constant term, the term that doesn't have the x, tells you the y-intercept. So these next two pages we'll skip over because the Flash application no longer works. We had an update to Smart Notebook and Flash no longer works with that. So in the slope-intercept form, that is the equation y equals mx plus b. Remember that m tells you the slope. It's the rise over the run. And b tells you the y-intercept, which is where the graph crosses the y-axis. So again, m is the slope, which is rise over run. And b tells you the y-intercept. It's where the graph crosses the y-axis. So you must have a line, which means no exponents, and you must have y by itself on one side. Normally you'll have two terms on the other side. One term that has an x, a term that doesn't have the x. The term that has the x tells you the slope. The number in front of x tells you the slope. The term that doesn't have the x is a constant. It tells you the y-intercept. So, on the next page, you've got an equation. You're asked to state the slope and y-intercept. That first equation is in slope-intercept form because y is by itself. Jensen, what's the slope of that line? You want to bet a pop on that? Is he right, Peyton? Why not? Why is it -2? Because that's the number in front of x. The number in front of x tells you the slope. The y-intercept is +3. The constant tells you the y-intercept. I like Coke, Jensen. So let's look at the second equation. Jensen, I'll give you a chance to win your pop back here if you want. It's your choice. Is that the equation of a line? Why not? So you're going to bet a pop on that? Double or nothing? Sure. Take all the time you need. This class ends at what? Around 1:30? That's how much time you have. No, I guess it's 2 o'clock, isn't it? 1:58.
6. 1:56. Ends this class.
Rocks. The question was, is this the equation of a line? You said no. Oh, you're saying it is an equation of a line? Okay, take your time. Da, 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 da. Pardon me?
It's not.
Why not? And that's your final answer for double or nothing? Is this the equation of a line, Keen? Jan? Yes, it is. We know it because there's no exponents, right? There's no exponents, so this is a line. You want to keep going here, Keen? This is fun. Or Jensen, this is fun.
It's like gambling. You're eventually so far in the hole that there's no point giving.
Oh, yes, there is.
So, I might just.
No, we'll take a break from you losing, from your losing streak. So it is an equation of a line because there's no exponents. So here's the next question. Is it in slope-intercept form, Declan? What is the definition of slope-intercept form? Let's look back on the previous page. Slope-intercept form is y equals mx plus b. So is this equation in slope-intercept form, Declan? Why not? Because you don't have y by itself. Sure, y is in the equation. You need to get y by itself. So sometimes we need to do some algebra to get y by itself. And in this case here, that algebra would be to subtract the x from both sides. That's what we would do to get y by itself. So you might write it like this, y equals 2 take away x. However, slope-intercept form usually has the x term first, which in this case is negative. The 2 is positive. Now it is in slope-intercept form. Now we have y by itself on one side, and on the other side we have two terms, one with an x, one that doesn't have the x. Brock, what's the slope of this line? Why is the slope negative 1? Because that's the number in front of x. What's the y-intercept? Positive 2. If we write the coordinates, it would be 0, 2. The y-intercept is where the graph crosses the y-axis. To get there, you don't go left or right. That is the reason that x is 0. You just go up 2 units, so y is positive 2. Okay, looking at the next equation. Olivia, is that a line? Sorry? How do we know? No exponents, right. No exponents, so it is a line. Cherry, is it in slope-intercept form? Why not? Because Jensen said it is? So you're just going to disagree with him? Sure. Chloe, why is it in slope-intercept form? Why not? You have to have y by itself. That's why it's not in slope-intercept form. So we need to get y by itself, doing some algebra. So you would subtract the 6x from both sides. And that would at least give us the y term by itself, but we're not done yet because we don't have y by itself. On the other side, we'll put the x term first, which is negative 6x plus 2. What's our last step, Brooklyn? How do we get y completely by itself? Is that right, Ava? She said subtract 2. Pardon? Why not? That's correct. How do we get y by itself? Yeah, because it's 2 times y. You have to divide everything by 2. All the terms by 2. And so this will give us, excuse me, y equals negative 3x plus 1 when you divide all 3 terms by 2. Now it is in slope-intercept form. So Roddy, what's the slope of this line? And what's the y-intercept? Right, which has the coordinates 0, 1. Right? So that is slope-intercept form. And you can see that it is a very valuable tool to graph a line. Because once you have the slope and the y-intercept, you can graph the line, which we will see some examples of. So the slope is negative 3 over 1. Okay, let's see if this works.
So funny.
Graphs, 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 graphs.
Okay, listen up.
I'm gonna graph some lines, gotta get them in slope intercept form. Hit that y-axis, put the intercept on, then use rise over run.
Welcome to the class, like what up, class is in session. I'm so pumped about the basic math lesson, graph on the board, skills so absurd that people like,
Man, that is one dope math nerd.
rolling in hecka deep, in my class will never sleep, getting that slope and y-intercept on the screen, draped in my corduroys, students sitting in front of me, probably should get on with this, making it rain practice sheets. Let's make graphing lines make sense. You'll be solving it, graphing it. Now it's time to start mathing it. Dashing up on this problem. When you finish, you'll be trashing. Solve for y, where's it hiding? Add and subtract to both sides and multiply and divide. Move things away from the y, kids. I'ma get that y alone. I'ma get that y alone. No, for real, slope intercept. That's y equals mx plus b. Claw it, combine it, get y alone too. Reverse PEMDAS tells you what to move. Now what's next to x? The slope is next to x. But what's that number left? Let's be the intercept. The b, the y, intercept is b. Start on the y-axis, graphs begin with the b. Now go and take the m now. The slope is next to c. Use the rise, then the run.
For every point you need. I'm gonna graph some lines, gotta get them in slope intercept form. Hit that y-axis, put the intercept on, then use rise over run. I'm gonna graph some lines, gotta get them in slope intercept form. Hit that y-axis, put the intercept on, then use rise over run. Let's get that y alone, that slope intercept bone. Let's get that y alone, for that slope intercept bone. Let's get that y alone, that slope intercept bone. Let's get that y alone, for that slope intercept bone. I'm gonna graph some lines, gotta get them in slope intercept bone. Get that y-axis, put the intercept on, then use rise over run.
Life over.
So remember, get that y alone. Slope intercept form.
Click here. Click here.
So once we have a line in slope intercept form, it's easy to graph. As you saw in the video, and we did examples like this in the last chapter, where you could use the slope to graph a line. You just had to have a point to start from. And now that point will be the y-intercept. But before we get there, is this a line, Declan? How do you know? No, that's not why it's a line. Is this a line? Jan? Is this a line? How can you tell by looking at an equation if it's a line or not? Liam? Sorry? Exponents. There's no exponents here. That's right. So therefore it is a line. Now the next question, is it in slope-intercept form, Declan? Get that y alone, right? Got the y alone. It is slope-intercept form. So now we can say the slope and the y-intercept. Sal, what's the slope? 1/2. That's right. And the y-intercept is the constant, the number that doesn't have the x, b. The y-intercept is 0,3. It's a point on the y-axis. You don't go left or right to get there. That is the reason that x is 0. And to graph a line from a point in the slope, you got to start with the point first. In this case, you're starting with the y-intercept, 0,3. And then you apply the slope. You rise 1 and run 2. That goes up 1 and to the right 2. And you can do that multiple times. Rise 1, run 2. You can also say that the slope is -1 over -2. We did that before as well. You can rise -1, which means go down 1, and run -2 is to the left 2. Down 1, left 2. Down 1, left 2. All of these points line up. Remember, whenever you're graphing from an equation, it's continuous data. Unless you're specifically told otherwise, it is continuous data, which means you draw a line through all the points, and we always put arrows on the ends of our graph. So there's that equation. So again, this slope-intercept form is very useful to graph a line. Makes it much easier to graph a line. All right, here's the next example. Is that a line, Peyton? Take out your earbuds. Is this a line? How do you know? No exponents. Is it in slope-intercept form? Why? How do you know? Huh? Because you got y alone. So therefore, you should be able to get the slope and y-intercept. Cherry, what's m the slope? What's m the slope? But you got to remember there's a negative there. That makes a difference. So you can say it's -3 over +4 or +3 over -4. When a fraction is negative, either the top or the bottom is negative. Brooklyn, what's the y-intercept? Huh? Take your earbud out. Kai, what's the y-intercept? Sorry? I can't hear you. That's right. The constant, the number that doesn't have the x, tells you the y-intercept. That's our b value, -1, but the coordinates of the y-intercept, because it's a point on a graph, you need an x and a y, is 0, -1, and that's where we start. We start with the y-intercept, and then we can apply the slope. If we rise -3, that's going down 3, and run +4 means 4 to the right. We can rise -3 again and run +4 again. Or we can rise +3 and run -4. Rise +3 and run -4. So the line will go through all those points. The fact that all the points that we put on there line up is a pretty good indication that we've done everything correctly. Applied the correct slope for each point. If we messed up on one of those, we didn't apply the correct slope to all the points, then the points wouldn't line up. So there's the graph of that line. Again, the slope is negative because it falls as you go left to right. So which line number matches each equation? The first equation is y equals 2x plus 3. What do we know about that line? And these are all lines because there are no exponents. So what do we know about that line, Brock? What do we know about that line? 2x plus 3. But what do we know about that line? And then we'll get to what the correct answer is. Is what? Plus 3, and what's the slope? Yep. 2 is correct. It's the number in front of x, which is 2 over 1. But it's also important to know that it's a positive value. Now, in this case, there's only one line that has a y-intercept of plus 3. And Brock is right. That is equation 4. Right? But it's also, in some cases, it'll be important to know what the slope is and what that means. The slope is positive 2. Remember, a positive slope rises as you go left to right. Now, it's really hard to know for sure to count 2 over 1 because you don't have grid lines here. But if you start at positive 3, which is the y-intercept, and you rise 2 and run 1, it certainly looks like that's that point right there. Okay? In this case, you don't necessarily need that to get the right answer, but in some cases you will. Now, that next equation actually is a line. Even though there is no x, there is a y, and the y is to the power 1. This is the same thing as y equals negative 4 x to the power 0 is really what it means. Because remember, anything to the power 0 is really 1. And we can also add a 0 onto the end of that if we want, right? But here's how we graph this line. Y equals negative 4. This tells us that no matter what x is, y is always negative 4. When x is 0, y is negative 4. When x is 1, y is still negative 4. When x is negative 2, y is still negative 4. We've seen these lines before. So that would be graph number 2. The next equation, y equals x plus 1. Princess, what do you know about that line? What do we know about that line? 2 things that you can tell by looking at that equation. Because it is a line, it is in slope-intercept form. So what do we know about that line? I just said that. Jan? What's the slope of this line? 1, or 1 over 1. What's the y-intercept? Also plus 1. That's your b value. So line number 1 has a y-intercept of plus 1, and if you rise 1 and run 1, that'll take you right there. If you rise another 1 and run another 1, that'll take you right there. So that is equation or line number 1. What do we know about that next equation? Kenzie? It is a line because there's no powers. It is in slope-intercept form because we have y by itself. So what are the slope and y-intercepts for that one? Right. So we can write negative 3 as negative 3 over 1. The only line that has a y-intercept of plus 5 is graph number 5. And if you start at that y-intercept and you rise negative 3, which means you go down 3 and run 1, that takes you right there, which is another point on that line. So that just confirms that that is graph number 5. So all we're missing now is graph number 3. This line, and it is a line because there's no powers. It is in slope-intercept form because we have y by itself. The y-intercept is negative 3, which graph 3 has a y-intercept of negative 3. And the slope is negative 5, which is negative 5 over 1. You can also write that as 5 over negative 1 if you want. A fraction is negative if either the top or the bottom is negative. And the reason I might write it like that is because I don't really have room on this graph to go down 5 units from this y-intercept. But I have room to rise 5 units and then run negative 1 unit. That takes us right there, which is a point on that graph right there. So that confirms that that matches graph number 3. Okay, so we're going to stop there for today. I'm going to put some questions on here that you should do for practice. And I will post these solutions to Google Classroom so you can check your answers. That should be 3 through 6. On page 349 to 350, yes. And again, I will post the solutions to Google Classroom so that you can check your answers. I would encourage you to do these for practice. And then after you get that written down, you can clear your desk so you can write your quiz.